Okay, we are going to move into talking about equations. And all the equations that we do right now are going to be linear. Does anybody know what makes an equation linear? What makes an equation linear? What does the name linear suggest when we graph it? It makes a line. It makes a line. Now, the exponents also play a role in what makes something linear. So I want you to look at this x, and 2x minus 1 equals 13. What is the exponent that is associated with that x? A 1. Okay? So that's what makes it linear. Now, we are going to solve equations where we have quadratics and cubics and lots of other things, but right now we're focusing on linear equations. And when we solve linear equations, we want to get something by itself. What do we want to do when we're solving? What's our goal when we're solving? Get x what? Good. So we want to isolate the variable. Okay? So that's our goal. We want to isolate the variable. We want to isolate the variable. Now, when we are doing that, there is a rule that we have to follow. There's a rule that we have to follow when we're doing equations. I call it the sibling rule because I have a 15-year-old son and a 17-year-old daughter. And when it is Madison's birthday and I give her $50 for her birthday, what does Bradley expect when it comes to his birthday? $50. Okay? And if Madison got to do something special when she turned 13, what did Bradley expect when he turned 13? Something special. So we have to keep that equilibrium with siblings. Okay? And that's what happens when we're doing equations also. So what we do to one side, we have to do to the other. So I was doing this lecture yesterday and I had somebody say, well, Alicia, couldn't that be the Thanos rule? And I still haven't figured that out yet, why it should be. Yeah, okay, so you get it, sort of, but I still don't understand why that's equal, the Thanos rule. So my daughter is writing up a paper for that student on why it doesn't, why it's not the same thing, because she's a big Marvel person. Not Thanos, but Marvel. So what we do to one side, we must do to the other. So another thing that comes into play here are what we call inverse operations. Inverse operations. So if I'm talking about addition, how do I undo addition? Subtraction. You're also adding the opposite. So remember, if I've got positive 2, I can add negative 2 to that. Okay? Because subtraction and adding the opposite is the same thing. So inverse operations play a key role here as well. What's the inverse of multiplication? Division. You got it. Okay, so our first one here is 2x minus 1 equals 13. So the first thing that I'm going to do is I'm going to get rid of that negative 1. How do I get rid of the negative 1? I add it. Good job. So I add 1 to both sides. Okay? 2x minus 1 equals 13. I add 1 to both sides, and I'm left with 2x equals 14. Okay? What operation is going on between the 2 and the x? Multiplication. How do I get rid of that? Good. So I get x equals 7. Now, a very good habit to get into in algebra in general is checking. Okay? Now, we're not going to check every one of these problems today because of time, but I do want to remind you how you check these problems. Okay? Once I have isolated my variable and I have the value of my variable, I take that value and I plug it back into the original problem for x. So when I check this, my check looks like 2 times 7 minus 1 equals 13. Is that a true statement? Yes, it is. It is a true statement. What if I got a false statement there? What if I got 12 equals 13 or negative 10 equals 13? Something's wrong somewhere. That's what that means. Something is wrong somewhere. Okay? Good. So our next one, negative 7 equals negative 5a plus 9. I want you to try that on your paper right now. Negative 7 equals negative 5a plus 9. I'm going to set my timer for 60 seconds. Okay, now this one is slightly different because we have our variable on the right-hand side, okay? You could move that variable to the left if you wanted to. Later today when we start talking about inequalities, that's something that I'm going to recommend that you do is move that variable to the left. However, it's completely mathematically correct to leave that variable on the right. So if we subtract 9 from both sides here, I'm left with negative 16 equals negative 5a. And then I'm going to divide by negative 5. When I divide by both sides by negative 5, for my answer, I get a negative 16 over negative 5. A negative divided by a negative is a what? Positive. So my answer here is 16 over 5. Now, we talked a little bit last week, or Tuesday, on simplifying fractions, but leaving them improper. This is an improper fraction, and it is okay for it to be an improper fraction. What I want to look at now is there something in the numerator and something in the denominator that I can simplify out? So is there a factor common to the numerator and common to the denominator? There is not. So this is an improper fraction, but it is also a simplified fraction. Now, you still have to simplify all your fractions. What you do not have to do is you do not have to turn it into a mixed numeral or a mixed number. Okay? Okay, this one, our next one, 7x minus 3 equals 5x plus 9. It has variables on both sides. It has variables on both sides. So what we have to do first here, the first thing that we want to do is move variables to the same side. Now, a good habit to get into is to move them to the left. And the reason for that is later today we're going to actually graph inequalities. And when we graph those inequalities, it's easier to graph them if you have written it with the variable on the left. Okay? So moving that variable to the left is going to be super helpful. So we are going to subtract 5x from both sides. Okay? 7x minus 5x is 2x. So we have 2x minus 3 equals 9. Okay? Then we are going to add 3 to both sides. And we get 2x equals 12. 2 and x are being multiplied together. So our inverse operation there is division. We divide both sides by 2 and we get x equals 6. Now, if you were going to check this, you're going to plug that 6 in for every x that you run into. So we're going to have 7 times x, and then we're going to have 5 times x. So every x that we run into. Okay? Now, the one on the right is more complicated. So I want us to think about a few things. Can I erase the one on the left? Has everybody got the one on the left written down? Going once. You can take a picture if you need to. Okay, I'm erasing. So, a lot of times students get a little bit confused when we're talking about parentheses and, we're supposed to simplify what's inside the parentheses. We're supposed to deal with parentheses first. What does that mean when I'm solving equations? So what we've got here is we have 3 sets of parentheses that we've got to do something with. So the very first question that you ask yourself, is there anything inside the parentheses that can be simplified? Okay? So when I say inside the parentheses, I am talking about this right there, the y minus 1, the y plus 2, and the y minus 8. That's what's inside the parentheses. And for every one of those, there is nothing in there that can be simplified. Okay? So the next question we say, is there a number that must be distributed? Okay? And so now what we're looking at is that 4, that 5, and that 3. Those need to be distributed. Okay? So let's do that. So we're going to take 4 and we're going to multiply it times y. Then we are going to take 4 and we are multiplying that by -1. Because remember, that subtraction sign belongs to that 1. We could rewrite that if we wanted to as y plus -1. So 4 times -1 is -4. Okay? Now we're distributing our 5. We need to distribute the 5 to the y and the 5 to the 2. So we have 5y plus 10. And then my last one, I'm distributing the 3 to the y and the 3 to the -8. So I have 3y minus 24. Now, we've got 4y and 5y on the same side. Okay? So here's 4y and here's 5y. Before I start dealing with that 3y that's on the other side of the equation, I want to combine like terms on each side of the equation. So we're not doing opposite or anything. What we're doing is we're combining like terms that are on the same side of the equation. So what's 4y and 5y? 9y. Okay? Now, whoops. -4 and +10 are also like terms. What's -4 and +10? Good. Okay. At this point, that's, whoops. It's not 6y, is it? There we go. 9y plus 6 equals 3y minus 24. At this point, Now we get the y's on the same side. Sometimes I see students, they'll go ahead and subtract that 3y before they've combined their 4y and their 5y. And that's not wrong. It's just a little bit messier. So if you get into the habit of combining like terms on the same side of the equation first, you're going to be better off. So what's my next step? Good. Okay, so then I'm left with 6y plus 6 equals negative 24. My next step? Good, subtract 6. So I have 6y equals negative 30. What's next? Divide by 6. And y equals negative 5. Okay? So I'm going to pause right here. How do we feel about the equations? Is it coming back to us on how to do the equations? It's coming back to us? So the things that you want to remember is you want to remember that your goal is to isolate the variable. And your rule is that whatever you do to one side, you've got to do the other. You've got to do both to the same side. Okay? Okay. Are we ready to step it up a notch? Yes, Alicia, we cannot wait to step it up a notch. Okay. So, here we go. Fractions, which we all love fractions. We dream about them, right? Okay. If we use the same principle that we used on our basic equations, what would my first step be here? What would I do first? What would I need to subtract or add or divide or what? Subtract 2/3. Okay? And that is a completely reasonable thing to do, is subtract 2/3. And if you subtract 2/3 from both sides, you're fine. You're going to get the correct answer. When you subtract that 2/3 from both sides, what are you going to have to do with 3/4 and negative 2/3? You're going to have to find the least common denominator. Okay? That's what I'm going to have to do. And that's okay. And that's okay. And we would get there, we'd multiply by the reciprocal, and we would be fine. I want you to start thinking about a different way to solve this problem. Because when we start solving rational expressions in a month or two, you're going to want to use this technique. So this is a technique that's important for things that we are going to do later on. So what I want you to do for this one is I want you to identify the LCD for all fractions, not just the 2/3 and the 3/4. What is the LCD for all of the fractions here? We've got 2, we've got 3, and we've got 4. It is 12. Okay? Then what we are going to do, we are going to multiply the entire equation. So every term in that equation by the LCD. Okay, so we've already determined that our LCD is 12. So what I'm going to do is I am going to multiply everything in here by 12 over 1. Now, I'm going to do this in different colors so you can see what I'm talking about. We're going to take 12 over 1 and we're going to multiply it by 1/2 x. Then we're going to take 12 over 1 and we're going to multiply it by 2/3. Then we're going to take 12 over 1 and we're going to multiply it by 3/4. Now, this step, students like to skip this step, and I don't recommend skipping it. Okay? So, okay. So the stuff in purple, the 1/2 x plus the 2/3 equals the 3/4, that is my original equation. 12 is what we decided was our LCD, and the fractional or rational form of 12 is 12 over 1. So I have taken 12 over 1 and I have multiplied it by each term in this equation. Now what I'm going to do is I am going to cross cancel. I'm going to cross cancel. So I am looking at that right there. My ones, they don't do anything. What number goes into 12 and 2? 2 does. Okay? How many times does 2 go into 2? Once. How many times does 2 go into 12? 6. Good. 6 times 1x is what? 6x. Okay? I'm doing the same thing right here. Okay? The 2 and the 1, we can't do anything. We leave it alone. What goes into 12 and 3? 3. Whoops. 3 goes into 3 one time. 3 goes into 12 how many times?
4.
Good. 4 times 2 is 8. Okay. Then we have 12 and 4. 4 goes into both of those. 4 goes into 4 one time. 4 goes into 12 3 times. Now, is 6x plus 8 equals 9 easier to deal with than 1/2 x plus 2/3 equals 3/4? Yes. Okay? Now, the key to this is that we have an equal sign. And we are solving for something. If you're not solving for something, then you've got to, if you're just combining like terms or something like that with no equal sign, if you're simplifying, then you are going to have to find your common denominator. But if you are solving an equation, then you multiply everything by the LCD. That's how you solve that. Now, go ahead and solve the problem on your paper. 6x plus 8 equals 9. Okay, did you get 1/6? Good. So now we are going to use this technique on a more complex problem. Can I move the screen? Okay. So here I have x minus 2 over 3 plus x plus 1 over 8 equals 5 over 6. Now, in order of operations, who can tell me the different kinds of grouping symbols we dealt with? What's the most famous grouping symbol? Parentheses. What's another grouping symbol? Brackets. And what's the third one that we don't always think about? Fraction bar. Okay? Now, in this problem right here, the first thing that I would do is I would put parentheses around my numerator. Okay? The reason for that is if you don't, you're not going to distribute a number that you need to distribute. Okay? And when we simplify out our greatest common factor, when we simplify out our least common denominator, you're going to be left with a number that has to be multiplied by that numerator, and it's got to be multiplied by the entire numerator. So you've got to start thinking about the fraction bar as a grouping symbol. So putting those parentheses around the top helps you to do that. It helps you to do that. Okay, now the first thing that we're going to do is we're going to find our LCD. LCD. Now you may be able to look at 3, 8, and 6 and tell me what the LCD is. However, sometimes you can't. And if we took 3 times 8 times 6, we're going to get a very large number. 3 times 8 is 24, and 24 times 6 is 144. Yes, 144. Okay? We don't want to deal with an LCD that large. We could, and it would be okay. It's just not necessary to deal with it that big. Okay? What I want you to do is I want you to realize how you can find the LCD. Now we've got 3, we've got 8, and we've got 6. The way that I would do it is I would take my largest number. What's my largest number there? 8. And I'd start writing down the multiples of 8. So I have 8, 16, 24, 32, and 40. So I have just said 8 times 1, 8 times 2, 8 times 3, 8 times 4, and 8 times 5. And then I would think to myself, well, does 3 and 6 go into 8? No. Does 3 and 6 go into 16? No. Oh, 3 and 6 both go into 24. So my LCD is 24. Now, if that doesn't work, then you can also write down the multiples of 6. Okay? And you can say, oh, there's one. 24 works. So writing down the multiples of these numbers will help you determine what the LCD is. Now, again, we are going to multiply each individual term by our LCD, which is 24 over 1. Ooh. So we're going to multiply everything 24 over 1. Okay? So 24 over 1 times, and I'm going to write those parentheses, x minus 2 over 3 plus 24 over 1 times x plus 1 over 8 Okay. So the blue is the 24 over 1 that we are multiplying each term by. The purple is our original problem. X minus 2 over 3, x plus 1 over 8, and 5 over 6. Those are part of our original problem. So now we are going to cross cancel. Okay, what goes into 3 and 24? 3 does. Okay, 3 goes into 3 one time, 3 goes into 24 8 times. This is where we're going to distribute. Right there. Okay, now I taught this lesson yesterday to my Math 131 class, and I've already had somebody email me back and say, hey, I've messed up here. The place that the student messed up was they didn't simplify the 24 and the 3. They just distributed the 24 everywhere and then got rid of the denominators. So make sure you are simplifying there. Okay? Make sure you're simplifying there. So here we've got 8 goes into both. So 8 goes into 8 one time. 8 goes into 24 3 times. Okay? For our last one, 6 goes into 6 once. 6 goes into 24 4 times. Okay. Do you know how to solve the rest of this problem? Yes. Do that now. I'm going to set my timer for 60 seconds. So solve this at your desk. Okay, did you get x equals 3? Are you still working on getting x equals 3? Okay, I distributed. I combined like terms. And then I isolated the variable. Please stop me if you're not sure where I got the x equals 3. Okay. So we have done fractions with, or we have done equations with whole numbers and integers. We've done equations with fractions. Now we're going to do some equations with decimals. And typically when students see the decimals, there's like, whoa, you said I couldn't use calculators. And that is true. You cannot use calculators. So we need to talk about how are we going to solve problems with decimals without the use of calculators. Okay, can I move from the screen? Okay. So, a couple things that I want to talk about before we get into exactly how to solve this problem with decimals. Let's say I was subtracting. Let's say I had 7/10 minus 67 hundredths. So this, I'm just straight subtracting here. 7/10 minus 67 hundredths. Now we're not using a calculator. How do I write this? So I have a horizontal math problem, which means it's written this way. I want to write it up and down so that I can do the subtraction and borrow and all that kind of stuff. How do I rewrite that so that I can solve it and get the correct answer? What? Good. And when I'm doing that, what am I doing? You hit 7. You're lining up your decimals. That's what you're doing. So I am going to write 0.7 minus 0.67. Okay? Do you see that right there? What do I need to put beside that first 7? What do I have to put? A 0. I need to put a 0 right here. Okay? 7/10 and 70 hundredths is the same thing. Think about if you had 7 dimes, how much money would you have? If I had 7 dimes, 70 cents. If I had 70 pennies, how much money would I have? 70 cents. Okay? So it's the same thing. So when you're adding or subtracting, sometimes you do have to line up those decimals. At this point, I would have to borrow from the 7. So I'd make that 6. My 0 would become 10. 6 minus 6 is 0. So my answer here is 3 hundredths. 3 hundredths. Okay? Now, You only line up your decimal when you are adding or subtracting. When you're multiplying, you don't have to line up your decimal. So it's kind of like when you're adding and subtracting fractions, you've got to have an LCD. But when you multiply or divide fractions, you do not. When you are adding, when you multiply or divide fractions, you don't. When you are adding and subtracting decimals, you've got to line up that decimal. When you are multiplying or dividing fractions, you do not. Okay? Yes, sir. Say that one more time. Do this one again? Yeah. Let's do a different one. How about that? Can I erase this one? Can I erase this? Okay. Let's add something. So let's say 0.4 or 4/10 plus 1.23 or 1 and 23/100. Okay, so I am adding this. So I am going to put my 0.4 or my 4/10. Then I am going to put 1.23 or 1 and 23/100. Okay? And so right here, my decimal's lined up. So I have to have that decimal lined up. And since I lined up that decimal, I've got to put a 0 right here. Okay? I've got to put a 0 right there. And once I've done that, then I have columns. So this situation we're adding, 0 plus 3 is 3. 4 plus 2 is 6. I bring that decimal straight down. And so then my answer is 1 and 63/100. Yes, ma'am.
In my math class in high school, we would always carry down the decimal, so then you could always have your place unless, like, if you write big like me.
Right. Bringing that decimal down first is a great idea. It's a great idea. Thank you for sharing that. Okay? We got to think way back for that one, don't we? Yeah, we got to think way back. Okay. Okay, I'm going to erase, okay? Okay. Now, that's a quick review on adding and subtracting decimals. Now, if I have 0.2 and I want to get rid of that decimal, and this is read 2/10. What can I multiply 2/10 by to get rid of the decimal? 10. And when I multiply by 10, that moves my decimal one spot. Okay? So if I multiply this by 10, I'm moving that decimal one spot, and I get 2. Okay? What if I have 2/10 and I multiply it by 100? How many spaces am I moving that decimal? 2. Okay? Now, do you see how I have this open spot where I've moved my decimal twice? What do I put in that open spot? A 0. That's what I put there. Put a 0 right there. So when I've multiplied 2/10 by 100, what do I have now? I have 20. Okay? Here I've got 24/100. If I multiply 24/100 by 10, I'm only moving my decimal one spot. Does that eliminate my decimal? No, it doesn't. I'm left with 2.4. And if my goal is to eliminate the decimals, multiplying 24/100 by 10 doesn't do it. It doesn't cut it. So I have to multiply this 0.24 by 100 to get rid of the decimal completely in 24/100. So we're talking about that because in this particular problem right here, I want you to realize I've got one decimal space, which is the tenths, and I've got two decimal spaces. The only decimal I would get rid of was the 2/10. So to get rid of all the decimals here, I've got to multiply everything by 100 because we have to do the same exact thing to every single term or to both sides of my equation. So just like we multiplied our fractions by the least common denominator, ladies, we have to do that here, but we're going to do 100. We're not going to do 10. Okay? So for this problem, I want to get rid of all the decimals. And when I get rid of all the decimals, it's going to be easier to solve. So I am going to multiply all of this by 100. So I'm going to have 100 times 0.2x. Then I'm going to have 100 times 0.24. And I better write smaller, right? Then I've got 0.08x. I'm going to multiply that times 100. Okay. So the purple, or the super dark purple, is my original problem. 2/10x plus 24/100 equals 8/100x plus 72/100. Then in red, I have every single term multiplied by 100. This first one, I've only got one decimal space. But when I multiply by 100, how many spaces does the decimal space get moved? 2. Okay?
Is doing that by reversal with the x by 100, is that going to make it 28?
It is. That's exactly right. So and the question was, is doing the 2/10 x, or the 0.2x by 100, does that make it 20? And the answer to that question is yes, it does. And I'm going to do that down here. So I have 100 times 0.2x. I am moving that 2 spaces, so I've got to put a 0 right there. Okay, so that becomes 20x. If you're going to make a mistake in this problem, that's where the mistake will be, is right there. You forget that 0 placeholder. So be careful with that. Now, 100 times 24/100, that's super nice. Because then we get 24. Okay? Our 800x, or our 0.08, we move that decimal and we're left with 8x. Okay, our last one, our 72/100, or our 0.72, we're left here. Now, is that something we know how to solve? How do we solve this?
Combine the like terms with the x to the other side.
Absolutely. We're going to subtract 8x. Good, and you're correct. You got it. So we're subtracting 8x from both sides. So I am left with 12x plus 24 equals 72. Okay, now I am subtracting 24 from both sides. I'm left with 12x equals 48. Now, if we need just a refresher on how to do subtraction, I've got 72 minus 48. 72 minus 48. I know we're going way, way back, but we want to make sure. The 7 becomes a 6 because I've got to borrow. 12 minus 8 is 4. What did I do wrong? Oh, I put 48 instead of 24. Okay. We're going to back up. What I am doing is I am saying 72 minus 24. 72 minus 24. Okay, the answer to that is 48. That's where I got my 48 from. So I borrow from my tens. Okay, 12 minus 4 is 8. 6 minus 2 is 48. Okay? This point we divide by 12. How many times does 12 go into 48? 4 times. Okay? Okay. Once you do a couple of these, typically students are okay with these. We're going to have to distribute in the next one. Can I move off this screen? Do we got it? Okay, cool. Okay, here we go. Now, I want us to think about multiplying straight numbers, just whole numbers. 2 times 3 times 4. When I am multiplying 2 times 3 times 4, okay, I multiply 2 times 3 together and I get what? 2 times 3 is 6. And then I multiply the 4. Okay, and I get 24. Once I have multiplied the 2 and the 3 together and gotten the 6, I'm done with the 2 and the 3. Like, once I've simplified those two, I don't deal with that 2 and the 3 anymore. I've got the 6 and then I move on. And I say 6 times 4. That's going to be a super important concept with this problem that we're doing up here. Because where students mess up is this right here. This 1100ths times 7,000 minus x. That's where students get confused. And what I want you to think about right now, as we move through this problem, is I want you to think about this 7,000 minus x the same way we thought about that 4. Okay? That 7,000 minus x is one quantity. It is all together. Until we distribute, that 7,000 minus x is one factor. Okay? That's what we're thinking about here. Now, I have 2 decimal spaces with my 1200ths x, and I have 2 decimal spaces with my 1100ths. What do I need to multiply everything by in this one? 10 or 100 or 1,000? 100, because I've got 2 decimal spaces. You've always got to multiply by whatever is the greatest. So I am going to multiply all of this by 100. And I know it's a pain when I go back and forth between colors, but I like to do that for you. So we've got 100 times 1200ths x. Then I've got 100 times this entire quantity. So I've got 0.11 times 7,000 minus x. Then I have 100 times 790. Okay. And again, those parentheses are where students get confused. Now the first one, 100 times 1200ths x, we're going to move that decimal 2 spots. So we're going to get 12x. right here, this 100 is my 2. This 1100ths is my 3. 7,000 minus x is my 4. Those are 3 things multiplied together. So once I deal with the 100 times the 0.11 and I move this over, I'm done with this part. I'm left with 11 times 7,000 minus x. You do not take that 100 into your parentheses, because you have multiplied that 100 times that 1100ths and gotten 11. So when you distribute that 11 across the parentheses, you have addressed that 100. Now what students want to do is they want to keep that 100 around. But remember, when we multiplied 2 times 3 and got 6, we didn't deal with the 2 or the 3 again, because we had addressed it and we had already multiplied those things. This is going to take practice, this type of problem right here. Okay? Then we have 100 times 790. Where is the decimal in 790? After the 0. So we're going to move it over. Okay. Now I can distribute. So I have 12x. 11 times 7 is 77. Then I just write down my zeros. (11 times negative x is negative 11x. And now it's much easier to deal with. I take 12x minus 11x. I'm left with 1x. Okay. Now I'm going to subtract 77,000. So I am left with x equals 2,000. Okay, I want everybody to stand up and stretch for about 30 seconds because I got to do formulas in the next 20 minutes. So stand up and stretch and shake your arms out, whatever you need to do to focus on me for another 20 minutes. Because what I have to say is fabulous information. It's good stuff. Good stuff. Good stuff. Okay. Are we ready to talk about formulas? So we are going to take all the principles that we've used on solving equations, and we are going to apply that when we have more than one variable in a formula. That's what we're going to do next. We're going to apply those principles when we have more than one variable in a formula. And this comes into play, it's most important when we are dealing with linear, and if we've got y equals 2x plus 3, or we've got 4x minus 2y equals 10. We've got to solve for that y. That's why that's important. Okay? So in this one right here, I've got P equals 2L plus 2W. Does anyone recognize that formula? Does anybody recognize that formula? What is it? It's the perimeter of a rectangle. Okay? That's not something that you need to know or have memorized. It's just what it is. Okay? It's the perimeter of a rectangle. We will use this formula later. Now what we are doing in this particular formula is we are solving for W. We are not plugging things in. We are not trying to, there's not an X for us to isolate. What we are isolating is the W. So we are going to use our principles of solving equations, and we're going to isolate this W. So the first thing that I'm going to do is I'm working towards getting that W by itself. So I need to get rid of the 2L. So what I'm going to do is I'm going to subtract 2L from both sides. Subtracting 2L from both sides. So I'm going to have P minus 2L. I can't combine P and negative 2L. They're not like terms, so I can't combine them. So I rewrite it as P minus 2L. At this point, I've got 2W left on the right-hand side, so I divide by 2. So P minus 2L divided by 2 equals W. Okay? Questions on that? Because students sometimes get confused because we are not combining like terms. Yes, ma'am? Why don't the 2's cancel? Oh, that's a great question. That's an excellent question. Okay? So the question is, why don't the 2's cancel? This 2 and this 2, why don't they cancel? In order for them to cancel, we have to have one here also. Okay? So we'd have to have one here, and then we'd have to pull it out, and then. That is such a great question, because when we start doing the quadratic, students get confused about that. And so I will tell you, you could go one step further. This is considered completely simplified, but if you wanted to do, you could do P over 2 minus 2L over 2, and then you could simplify that. So that is an acceptable thing to do. And that would be your formula. But both of these are considered simplified. Okay? Thank you for bringing that up. That was a very good question. Okay? Can we go to the next one? Okay. Solve for H. Solve for H. Now this one, we've got a fraction. We have B and we have H. So we have to get rid of that fraction. We have to get rid of that fraction. Before we do that, any clue what this one is? It is. It's the area of a triangle. Good job. You guys must have had fun in geometry. Area of a triangle. That's what that is. Again, not something you need to know. But we are solving for H in this one right here. Sometimes in this one, students get confused because they've got to get rid of that fraction. They've got to get rid of that fraction. What do I need to do in order to get rid of that fraction?
Shouldn't the fraction be distributed into B and H and like break them up?
Okay. You would not want to do that because this is not addition. Okay, so the question was, do I need to give this 1/2 to the B and the H? And that is an excellent, excellent question. So I want us to look at this problem right here. What is happening between the 1/2, the B, and the H? Multiply. We're multiplying every one of those, okay? That's like the 2 times the 3 times the 4. So once we've dealt with the 2 and the 3 and gotten 6, we don't deal with that anymore. We do 6 times 4. That's what's happening here. We've got 1/2 times the base times the height. That's what's happening. Now, the difference between what's happening there and what's happening right here, what operation is happening right here? Subtraction. That's why we can give the 2 to the P and the 2 to the negative 2L. It's because of that. So there is a difference between addition and subtraction and multiplication. That's a great question too. Thank you for bringing that up. So, you multiply by the bottom number. That's exactly what you do. You multiply by the bottom number. We're actually, it's called multiplying by the reciprocal. So, what's the reciprocal of 1/2? 2 over 1. That's what we're multiplying by. So we're going to multiply this 2 over 1. just so you can see that in a different color. So then I'm left with 2A. These two cancel. And I would encourage you to leave that A capitalized. Sometimes a capital letter means something different than a lowercase letter. In this situation, that capital letter means area. So typically it's a capital A that denotes area. So think about it like your passwords. Does it matter if a letter is capitalized in your passwords? So if it's capitalized here, leave it capitalized. Okay? Now, I'm solving for H, so what's my final step? Divide by B. So I would get 2A over B equals H. Now, could I rewrite that as H equals 2A over B? Could I rewrite that? I could. Both are acceptable answers. Both are acceptable answers. Okay, can I go to the next screen? Okay, here we go. This one we are solving for P, and this is the most challenging one that we're going to do today. This one we're solving for P. What students want to do in this situation, and this is the wrong way. I'm writing it right here. Wrong. Wrong. Okay? What students want to do is they want to say, oh, well, there's P. I'm just going to subtract PRT from both sides and get A minus PRT equals P. Okay? What is the problem with this method? What is the problem with this?
PRT are all multiplied.
Yeah. So we've got a P here, but what else do I have over here? I've got another P. Okay? So I really haven't solved for P. I've solved for one of the P's, but I've left another P somewhere else. So it's not going to work. That's not how it works. Okay? So this is the wrong way to do it. Let's do it the right way. This is going to be super important if you take pre-calculus algebra, because it is a method that's used a lot when we find inverse functions. Okay, and that's probably some terminology that might scare you a little bit, but it's not bad. But it's used a lot when we do inverse functions, this method. So we have a P right here, and we have a P right here. Is there a property that would allow us to pull out that P? Is there something that I could do to where I could get that P by itself? So if I had my P right here, so I need my P. Okay, is there something that I could do and put other stuff in parentheses that pulls that P out? Okay, let's think about this. Okay, 2x plus 8. Is there a 2 in both of those terms? 2x, there is. Okay, there is. Does the distributive property allow me to pull that 2 out? So it's the opposite of what we typically do with the distributive property. So we're actually factoring. So if I pull that 2 out, what am I left with inside parentheses? X plus 4. Excellent. X plus 4. Okay, so I'm still using the distributive property here. I'm just doing the opposite of what I usually do with it. Okay, so if I pull this P out, P times what gives me P? 1. P times what gives me PRT? Good. That's the step that students miss. They forget that we can use the distributive property to pull something out. So I have actually factored out the greatest common factor between P and PRT. Just like here, I factored out the greatest common factor of 2 and 8. Okay, I pulled that out. So now I've got it to where I can isolate my P. What do I need to divide by? I'm going to divide by everything that's in that quantity in my parentheses. So I have 1 plus RT. That's what I'm dividing by. And you can put it in parentheses to keep it clear in your mind. But remember, a fraction bar is a grouping symbol. So my final answer is A divided by 1 plus RT. And if you have that 1 plus RT in parentheses, you're fine. You're fine. Okay, can I leave this screen? In this class and in the next class that you take, this is the type of problem that you will use this skill the most, is putting something in linear form or y equals mx plus b form. So what we have right here is we have a linear equation that is in what we call standard form. Now that is not terminology that you need to be worried about right now. So it's 2x minus 5y equals 7. 2x minus 5y equals 7. What you want to do is you want to solve for y. Now be careful. Who does that minus sign belong to? The 5 or the 5y. Okay? So was there a question up here? I'm sorry. We're good? Okay. So I am going to subtract 2x from both sides. Now, what happens is when I get rid of that 2x, students drop the negative. They drop their negative. Okay? And they just bring down the 5y. Don't do that. Don't drop it. Okay? You want to be careful with that. You want to be careful with that. Okay? Now, okay. What did I do? I did. I changed my x to a y. How's that? Is that better? So we've got negative 5y equals negative 2x plus 7. What am I dividing by? Negative 5. Now, you are technically correct if you write it like that. It's not fully simplified because we are moving towards getting it in y equals mx plus b format. And when we put it in y equals mx plus b format, we separate that. Because we're typically, when it's in y equals mx plus b format, we are graphing. So go ahead. You're going to be happier if you get in the habit of doing y equals negative 2 over negative 5x plus 7 over negative 5, because that's y equals mx plus b. What happens with the negative and the negative? That's our slope, which we haven't really talked about yet, but what happens with the negative and the negative? Because it's positive. So we're going to have y equals 2/5 x minus 7/5.